Hello, in this video we will do 5 examples of solving homogeneous differential equations. So this is all about homogeneous differential equation and substitution transformation. Um, how do you know if you can if something is a homogeneous differential equation? Well, if you do some kind of substitution, for example, if you plug in t of x for your x and then your y t of y, and if it spits out anything in this form of t raised to the n times f of x comma y, then f is said to be a homogeneous function of degree n. So let's let's do some examples and determine if the function is homogeneous. If so, determine the degree. So we're not solving, we're just figuring out if these equations are homogeneous. So if you look at question 1, we have f of x comma y equals x cubed plus y cubed. So first step is you plug in your x and y for t of x and your y t of y. Okay, so all you do is replace your x with t of x and then you replace your y with t of y. So that's going to be t of x to the third plus t of y to the third. So what is t of x to the third? That is t cubed x cubed. Plus what is t of y to the third? That is t cubed y cubed. Now, what you can do next is you can factor out then what you can do next is factor out a t cubed. So this would be t cubed of x cubed plus y cubed. And so this is, so when you have x cubed plus y cubed gives you the same original function, right? So you can say, instead of rewriting x cubed plus y cubed, you could just say it's this function, f of x, y. So I'm just replacing this with f of xy because f of xy is this function. So you tell me, is this a homogeneous function? Is it in the form of Tn times f of x comma y? Yes. Yes, it is. Um, yes, it's homogeneous. And we got to figure out what the degree. The degree is this n power, which is 3. So the degree is 3. Okay. Okay, let's move on to the next example. So example 2, we got to determine if it's homogeneous. So first step is plug in your x and y with t of x and your y t of y. So that's the first step. Okay. So your x is going to be t of x. So this x right here is going to be t of x plus square root of x times y. So your x is t of x times t of y. So that's going to be t of x plus square root of what? Well, inside, what can you multiply the t's and the t's? So that's t squared. And then you have this x and this y, right? So is there anything else we could do or simplify? Yes. Inside the square root, it looks like we could factor out t, 1t, because the square root of t squared is t. So it's going to be t square root of xy plus, and then this is t of x. Okay. Anything else you can do? Since we have, yeah, it looks like they both have a t. So you could factor out a t, so this would be x plus square root of xy. Now, is this a homogeneous? Yes, because it's t times f of xy. So this is f of xy, right? This is what you started out with. So yes, it would be a homogeneous. And what would be my nth power? 1. So it would be degree 1. Okay, let's do example 3. So first step, plug in your x and y. Replace your x with t of x and replace your y with t of y. So it's going to be, your x is going to be t of x squared plus 3, and your x is t of x times y. I'm going to put it down here. My y is t of y squared. So when you kind of clean that up, that's going to give you, so this right here would be t squared, x squared, and then if you FOIL this out, this is going to be plus 3t cubed x y squared. And then you can take out, from these two terms, you could take out a t squared, plus t squared x squared plus 3t x y squared. And as you can see, this is not homogeneous because this is not the same thing as this, right? You want to get f of xy or your original function, so not homogeneous. Okay, now you can tell if it is a homogeneous. Some more vocabulary. A first order ordinary differential equation in the differential form is m of x comma y d of x plus n of xy dy equals 0 is homogeneous if both coefficients of m and n are homogeneous functions of the same degree. Okay, so yeah, yeah, m and n are both homogeneous if you could put it in the homogeneous form, right? So let's talk about steps for solving a homogeneous first order ordinary differential equation. What you want to do, step 1, is substitute y equals u of x or x equals v of y. And you want, hint, if m of xy is less complicated than xy, and if n of xy is less complicated, then you use y equals ux. So basically, if your m is less complicated, then you're going to substitute x equals vy. If your n is less complicated, then you would substitute y with u equals u, y equals u times x, right? So it all makes sense when we do an example. And then step 2, it says simplify. Notice we have now simplify. Notice we now have a separable differential equation. So we will continue solving the method of separable equations. So that's where you have to take, if you go back to separable, you have to take the integral of both sides, etc. And then step 3, resubstitute our variables to arrive at final answer. So this substitution is very similar to a u substitution. When you change either the y or x, you will also need to change / substitute the dy or dx as well. Okay, let's start with example 1. Example 1 says solve the homogeneous first order differential equation of x minus y of d of x plus x dy equals 0. Okay, so first we got to determine if it's actually a homogeneous. So step 1, check if it's actually homogeneous. So this is your M, this is your N. So the rule is your M, you plug in your X and your Y for X, T of X and T of Y, right? So here's your M, replace your X with T of X and replace your Y with T of Y. So it's going to be T of X minus your Y, which is T of Y. And it looks like you can factor out a T. So this is X minus Y. So this is definitely homogeneous, right? It's T times your T of X. It's T times your original function, which we got, right? What about your N? So your N is going to be N of T of X, T of Y. So your N is X, so it's going to be Uh, I see we don't have a Y, so you just replace your X with T of X. And then our Y is just T of Y. Wait, so it's going to be your X, you're going to replace your X with T of X, and then, yeah, so that's T of X, which is equal to T of N of X comma Y. So you take out, if you factor out a T, yes, it is. Because if you factor out a T here, you're going to still get your original function. So yes, it's just, it is homogeneous. So they're both homogeneous. Your M and N are both homogeneous. So it is different. It is a homogeneous. So now what you do is you got to figure out which one is less complicated. Is your M less complicated? So your M is X minus Y, or is your N less complicated? Your N is X, right? So I believe our N is less complicated. Okay. So if your N is less complicated, you're going to substitute your Y. You're going to substitute Y equals UK, U times K, and then let U of K. Then what you do is you take your derivative of Y. So you kind of have to use the product rule, right? So if your Y is U times K, and we got to find Y prime, so you have to use the product rule. Here's your F, here's your G. So your product rule is F prime of G plus G prime of F, right? Okay, so my F is U, my F prime is dx. No, my F is du. I mean, my F prime is du, and then my G is, this should be an X, not a K. So my G is X, and then my G prime is dx. So if you take the derivative of that, it's going to be F prime of G. So F prime is du times G, which is X, plus G prime, which is dx, times F, which is U. Okay. So you get, if you simplify it, it's going to be, you could put this in front. It would be U dx plus X du. Okay. Then what you do, step two is plug in and substitute and simplify. So, okay. So if you go back to here, you're going to replace your y with ux, right? And then you're going to replace your dy, so dy with this. So this is your dy, right? This is your y, this is your dy. So yeah, it's going to be, so step two, plug in and substitute and simplify. Okay. So it's going to be x minus, and then you're going to replace your y with ux dx plus x times, and then you're going to replace your dy with this whole thing, u dx plus x du. Which equals to 0. And then I guess what you could do is, you see this dx? Foil out that dx. So it's going to be x dx minus ux dx. Then what about here? I guess you could FOIL out this x. So this is going to be plus x u dx plus x squared du equals 0. Right? And then what you want to do is kind of get, okay, so what you want to do is we want to get all the x's, and we want to get all the x and dx on one side and all the x and du on the left side. So what I would do is, wait, first off, can we collect like terms? Uh, I think we can, or something cancels, right? You have x dx. So if you simplify this, you're left with x dx plus x squared du. Oh, this cancels, right? These are practically the same thing. So these cancels. So now you're just left with x dx plus x squared du equals 0. And then what I would do next is move the x dx on one side to move this to the right by subtracting x dx. So on the left, you're left with x squared du. And then on the right, you're left with negative x dx. Okay. Then what you want to do is yeah, you want to get all the x's on one side and all the du. So maybe I should also get rid of this x squared by dividing both sides by x squared, right? So you have this cancels, you're left with du equals, what's negative x over x squared? That's negative 1 over x. And then once you have the du's and all the x's on one side, you can take the integration of both sides. So what is the integration of du? It is u. What is the integration of negative 1 over x dx? That's negative ln of absolute value of x plus c. And then what you're going to do is resubstitute. So step 3, we substitute. So what did we had as a substitution? We substituted y equals u of x, right? So as you can see, we don't have a y, we only have u's. What you have to do is get u by itself. So you would have to divide both sides by x. So u is going to be y over x, okay? Then you would substitute your u with y over x. So this is going to be y over x equals negative ln of absolute value of x plus c. Then go ahead and cross multiply because you want to solve for y, right? Go ahead and cross multiply. 1 times y is y. And the next times this whole thing is negative x ln of absolute value of x plus c times x, right? Because you're multiplying everything by x. Okay, so this is your final solution. We don't have to solve for c because we don't have an initial value. Okay, so go ahead and copy that down. And now let's move on to example 2. Okay, example 2 says solve the homogeneous first order differential equation. We have x of dx plus parentheses y minus 2x of dy equals 0. So what is my m and what is my n? So my m is x, my n is y minus 2x. It says solve the we don't have to check for homogeneous because it says it is already. So what I'm going to do is first, I'm going to skip the first step, and I'm just going to figure out which one is less complicated. So which one is less complicated, the m or the n? M is definitely less complicated, right? M is less complicated. So that means you're going to substitute x equals v times y. And you then you would have to take the product of this rule, or dx is what? So you have to apply the product rules. Your f is v and your g is y. So my f prime is, what's the derivative of v? dv. And then my g prime is, what's the derivative of y? dy. So product rule is f prime of g plus g prime of f. So f prime is dv, g is y, plus g prime is dy, and then f is v. Okay. So that would be, you kind of clean this up. You could put this, you can rearrange this. I'll put this in front. So it's going to be v dy plus y dv. Okay, so that's your dx. Then step 2 is substitute and simplify, create a separable differential equation. Step 2. Okay, so what we're going to do is replace, what are we going to do? We're going to replace x with vy, and then you're going to replace dx with v dy plus y dv. And then that's it. So you're going to replace x with vy, and then you're going to replace dx with v dy plus y dv. So that what's going to turn out, it's going to look like this. It's going to be xy times v dy plus y dv. See, I just replaced x with vy, and then I replaced dx with v dy plus y dv. Okay. What's next? Plus, I think we just leave this as it is. Yeah. So it's going to be y minus 2 times, actually just replace x with vy dy. Okay. And then if you FOIL this out carefully, you should get v square y dy plus v y square dv plus, if you FOIL this out, this is y dy minus 2vy dy equals 0. And then if you kind of rearrange it, you're going to get v square y dy plus y dy minus 2vy dy plus vy square dv equals 0. And then what can we do? It looks like on here, see how they have like all these three terms? You could factor out a dy and you can also factor out a y. So it's going to be y dy of v square plus 1 minus 2v plus vy square dv equals 0, right? Uh, then can we separate? So step 3 is separate. So just go ahead and cross multiply. Or maybe I would subtract this vy squared dv because, yeah, subtract this to the right. Cancel, so you're left with y dy v squared plus 1 minus 2v equals to the negative vy squared dv. Okay, then go ahead and, so we're going to separate, so we're going to cross multiply. So that will give you, if you cross multiply, it should give you y over y squared dy equals to negative v over v squared minus 2v plus 1 dv. And then over here, y over y squared could be canceled as 1 over y dy equals to negative v. Right over here, I just move this negative 2v to make it easier. You have negative v parentheses v minus 1 square dv. Then what I would do next is, now you have all the, you did separate it, everything is good. You have the dv's and the v's here, and then the y's and the dy's on the left. That's perfect. now you would integrate. So step 4, integrate. You get integration of 1 over y dy, and then in the integration on the left would be negative v over v minus 1 square dv. This one's easy. The integration of 1 over y dy is the ln of absolute value y, but this one is a little bit tricky. Could we do u substitution? No, that wouldn't work. I think we'll have to do what's called partial fraction. So let's figure this out. So you have negative v over v minus 1 squared, and then on the right, we're going to do partial fractions, so it's going to be a over v minus 1 plus b over v minus 1 squared. Okay. Then what you would do is multiply everything by the LCD. By LCD, which is v minus 1 squared. So if you do that, you're going to get negative v equals a times v minus 1 plus b. And if you flow this out, this is going to be av minus a plus b. And then you have negative v here. And then so this is one term, and then this is actually one whole term. So on the AV stay the same. This is plus negative a plus b. So you kind of like have to set up as two different equations. You could say that AV equals negative v, and then negative a plus b equals to 0 because it's a constant. So you could say 0 equals to negative a plus b. And if you got rid of this v, you would say a by dividing both sides by v. You would say a equals to negative 1. And then if a is equal to negative 1, that means it's going to be 0 equals negative times negative 1 plus b. So negative times negative is positive 1 plus b. And then if you solve for b, you're going to get b equals to negative 1. Okay. So you would set it up as, oh man, I am running out of space. Here, let's move it to the left. Okay, so if you're going to rewrite this as the integration, on the left it was the integration of 1 over y dy, and then on the right it's the integration of negative 1 over v minus 1 dv plus the integration of negative 1 over v minus 1 square dv. Right? Because if our A, what did we say our B was -1 and our A was -1. Oh, my A was -1 and my B was also -1. So yeah, so that's how we got from this to this. So let's do this side. So how do I take the integration of -1 over v minus 1? You would have to do u substitution. My u is going to be v minus 1. So my du is going to be dv. So that would be the integration of -1 over u du. Plus over here, how would we do this? You would have to do u substitution, and my u would be v minus 1. And then my du is going to be dv. So that's going to be the integration of -1 over u squared du. Okay, so what's the integration of -1 over u du? That is negative ln of absolute value of u. Plus, what is the integration of -1 over u squared? It is not ln. Instead, it's like this -1 is a constant, so you could put that in front of here, and then this would be u to the -2 du. So if you take the integration of that, that's going to be it would be positive 1 over u. Okay, so put it all together. On the left side, the integration of 1 over y dy is ln of absolute value of y. This is negative ln of absolute value of u plus 1 over u plus c. And then what you could do is plug in your u. So this is negative ln absolute value u, which is v minus 1, plus 1 over v minus 1 plus c. And then here, I'm running out of space, so move it to the right. Then what you do is plug in your substitution. Our substitution was x equals vy. Thing is, we don't have an x, so you have to like solve for y. I mean, solve for v, because we have v's. So your v is going to be, if you solve for v, it would be x over y, right? So it's going to be ln of absolute value y equals to negative ln of v, which is x over y minus 1 plus 1 over x over y minus 1 plus c. And I guess you could simplify here, right? X over y minus 1 is like x over y minus y over y. And then the same thing here, you need to find a common denominator. That's x over y minus y over y. I'm running out of more space, so I'm going to move it to the right. Okay, so let's simplify. So this is going to be, if you simplify the left, it's going to be the ln of y on the left equals negative ln of x minus y plus 1 over x minus y over y plus c. So this is going to be ln of absolute value y, which is negative ln of x minus y over y, plus over here, 1 divided by x minus y over y simplifies as you just flip it. So it's going to be y over x minus y. Let's see. What do I need? What can I do next? Yes, right here, you see you have a minus here. What do we do with a number in front of a log or natural log? It's a power, right? So this is going to be ln of absolute value of x minus y over y to the negative 1. And then I guess you could simplify this. This to the negative 1, you can just flip it. So it's going to be ln of y over x minus y plus y over x minus y plus c. And what else can I do? I could simplify this. I could simplify this more. You have an if you want to expand, we're dividing. This would be ln of absolute value y minus ln of absolute value of x minus y. Then this stays the same. And then this is still ln of absolute value y. And I guess this could be your final answer. Okay, that was all that on that problem. So let's move on. Let's move on to example 3. So example 3, solve the homogeneous first order differential equation. And you have x dx plus sine square of y over x, parentheses, y dx minus x dy equals to 0. What can you say about this problem? Is it even it is homogeneous, it's in a different form. So I guess what you would do is kind of FOIL this out. So this stays the same, x dx. And if you FOIL this out and this out, you would get, so if you FOIL this with this, you're going to get y sine square of y over x dx minus x sine square of y over x dy equals 0. And then which one is less complicated, your m or your n? So I think your n is less complicated. Right? This is your n. I mean, your m, no, your n. So your n, this is less complicated. So you could say n is less complicated. So what we would do is let y equals u of x and dy. dy is the derivative of this. So how do you take the derivative of this? Product rule, right? Your f is u and your g is x. So my f prime is du and my g prime is dx. So my dy is going to be u dx plus x du, right? Okay, step 2, substitute separable differential equation. Okay, so we said that our u is equal to ux and our dy is this. So let me just kind of box it so you know what you would have to substitute. Like y is this, you're going to replace this y with ux, and then we're going to replace dy with this. That's it. So when you do that, you should get this x dx plus sine square of ux over x bracket ux dx minus x u dx plus x du equals 0, right? So when you simplify that more, you're going to get x dx plus sine square of u, and you have ux dx minus ux dx minus x squared du equals 0. And then you get x dx minus x squared sine square of u du equals 0. Then what you would do is like separate. So get all the du's and dx on one side. So you would get x dx minus x squared sine squared of u du equals 0. Oh, maybe move x squared. Yeah, move this to the right, all this. So you would have to add x squared sin squared of u to u. So you get x dx on the left, and then on the right, you're left with x squared sin squared of u u, and then cross multiply. Cross multiply, so that would be on the left, it's going to be x over x squared dx, and then on the right, it's going to be sin squared of u du, and then x over x squared is 1 over x dx, and then on the right, it's sin squared of u du. Okay, now that you separate it, you have all the x's, all the u's and du's on. You have the x's and dx on the left and the u's and du's on the right. Now you can integrate. So on the left, it's going to be the integration of 1 over x dx. On the right, it's going to be the integration of sin squared of u du. The left is easy. The integration of 1 over x dx is ln. The right, you might have to use what's called the half angle identity. So this sine square of u is the same thing as sine square of ax equals to 1/2 minus 1/2 cosine of 2ax, right? So you're basically taking the integration on the right, it's going to be 1/2 minus 1/2 cosine of 2u du. So what is the integration of 1/2? That is 1/2 u. What is the integration of negative 1/2 cosine of 2u? It would do u substitution, right? Your u would be 2u, and then it would be simplified as negative 1/2 of sine of 2u all over 2, and then plus c on the right. And then what is the integration of 1 over x dx? It's the ln of absolute value of x. Okay. And so on the left, it's going to be ln of absolute value of x equals 1/2 u minus 1/4 sin of 2u plus c. Now you're going to substitute. We said that y was equal to ux. And as you can see, we don't have a y. We need to solve for u. So when you solve for u is going to be y over x. Okay, so on the left, it's going to be the ln of absolute value of x equals, replace y with ux, so it's going to be 1/2 times y over x minus 1/4 sin of 2y over x plus c. And that's it. That is your final answer. Okay, 2 more examples. Okay. Example 4, solve the homogeneous first order differential equation. So first step, and this time we have initial condition of y of -1 equals 1. So this whole thing is my n. This whole thing is my n. So which is less complicated, the m or the n? N is less complicated, right? So you're going to say let y equals ux, and then my dy is going to be, you have to use the product rule, so that's going to be u dx plus x du, right? Your f is u, f prime is du, and then your g is x, g prime is dx. So when you take the derivative of this is what you get. So let me box it. We will probably have to substitute it. So what you're going to do is now substitute. You're going to substitute, what are you going to substitute? You're going to substitute dy with u dx plus x du, and then you're going to substitute y with ux. That's it. So when you do that, you should get x squared plus 2 times ux squared of dx minus x times ux times u dx plus x du equals to 0. Okay, step 2 is simplify. So go ahead and simplify FOIL so you get x squared plus 2u squared x squared dx minus ux squared of u dx plus x du equals 0. Okay. Clean it up more, you get x squared dx plus 2u squared x squared dx minus u squared x squared dx minus u x cubed du 0. And it looks like you can combine these two terms. So when you combine that, you get x dx plus u squared x squared dx minus ux cubed du equals 0. What could you do next? Yeah, over here, it looks like you could factor out a dx and an x squared, right? So go ahead and factor that out. So factor out an x squared and dx, and you're left with 1 plus u squared minus u x cubed du. So 0. Then what I would do is move this ux cubed du to the right by adding ux cubed du. You get so you would get x squared parentheses 1 plus u squared dx, and then over here this is going to be u x cubed du. Then you would cross multiply, right? So you're going to get x squared over x cubed dx equals to u over 1 plus u squared du. And then over here, x squared over x cubed simplifies as 1 over x dx. And then over here, just leave it as it is. There's nothing you can do. And then on the left, take the integration. So the integration of 1 over x dx equals the integration of u over 1 plus u squared du. The left is easy. The integration of 1 over x dx is ln of x. Over here, how do you take the integration? You would have to do, I think you would have to do u sub. And don't use u as that instead. Use a different letter, maybe a. So if a equals 1 over 1 plus u squared, dA would be 2u du. And then get rid of this 2 because we don't have a 2, right? We would have to multiply both sides by 1/2. So that's going to be 1/2 dA equals to u du. So this simplifies as 1/2 of 1 over a dA. So on the left, it's ln of absolute value of x equals to 1/2 ln of absolute value of a plus c. And then what we'd said that a was 1 plus u squared, so that's going to be 1/2 ln, and then a is 1 plus u squared plus c. And then go back to your substitution. What did we say? What did we substitute? We substituted y with ux. So we substituted y equals ux, and I think we need to solve for x, so you're going to have to divide both sides by x. So you get u equals y rect. That's going to be 1/2 ln of 1 plus u, which is y over x squared plus b. That's going to be 1/2 ln of 1 plus y. If you're squaring this, this would be y squared over x squared. Let's see. Then you got to solve for c because you have an initial value. So plug initial value. So our initial value was your x was -1, your y was +1. So it's going to be ln of absolute value of -1 equals, so 1/2 ln of 1 plus my y, which is 1 square over -1 square plus c. The ln of -1, or the absolute value, well, we know the absolute value of -1 is +1, and then the ln of 1 is 0. And then over here we have 1/2 ln 1 square over -1 square is 1, +1, plus 1 is 2, plus c. So your c is going to, and then just move this to the left, so your c is going to be -ln of square root 2. Okay, so your final answer is going to be ln of absolute value of x equals to 1/2 ln of x squared plus y squared over x squared minus ln of square root 2. That's it. And that is your final answer. And yeah, one last example. We're going to copy that down. Move on to example 5. Okay, so example 5 says solve the homogeneous first order differential equation y of x squared plus y squared dx plus x parentheses 3x squared minus 5y squared dy equals 0, and we're given an initial condition of y of 2 equals 1. Okay, so first step, figure out which is less complicated, your m or your n. So this is your m, this whole thing is your n. So which is less complicated? Yes, m is less complicated. So you're going to substitute or let x equals v times y. And then your dx is going to be, so you use the particle, your f is x, your g is y. So f prime is dx. And then your g prime is dy. If you apply the particle, your dx is going to be v dy plus y dv. And then if you said that, so I'll substitute that in, I'm going to box it, and then we said that x equals vy. I think we'll have to solve for y, so not y, solve for v, so v is going to be x over y. Let me box that, because we might have to substitute that in. So if you go back to your problem, you're going to substitute x with, you're going to substitute your x with vy, and then you're going to substitute your dx with v dy plus y dv. And what do you get? So when you do that substitution, you're going to get a really complex one. It's going to be y of parentheses vy square plus y square parentheses v dy plus y du plus vy of 3 parentheses vy square minus 5y square dy equals 0. Okay. What do I do? Vy square, so if you clean this up more, this would be vy square is v square y square plus y square. And then you have v dy plus y du plus vy. And then 3 times vy square, that's going to be 3v square y square minus 5y square of dy equals 0. Okay, clean it up a bit more. I guess if you follow this y out, it's going to be v square y cubed plus y cubed times v dy plus y dv plus 3v cubed y cubed minus 5v y cubed dy equals 0. Okay, and when you FOIL it out even more, you're going to get v cubed y cubed dy plus v square y fourth dv plus vy cubed dy plus y4 dv plus 3v cubed y cubed dy minus 5vy cubed dy equals 0. So basically, when you really clean it up, you should get this. I'm just going to go one step further. So when you FOIL it out, clean it up, you're going to get this. 4vy cubed dy parentheses v squared minus 1 plus y4 dv times v squared plus 1 equals 0. So yeah, when you clean that up and then move this to the right, cancels, so you're left with 4v y cubed v squared minus 1 dy equals to negative y to the fourth v squared plus 1 dv. Then you would cross multiply and you should get 4y cubed dy over y4 equals to negative v squared plus 1 dv over v. Okay. Over here, if you clean it up, the y cube over the y fourth, that's just 4 over y dy. Over here, there's nothing you really can do. You can't really do much. Besides, this v squared minus 1, that's a perfect square, so that factors out as v plus 1 times v minus 1 dv. This one's easy, it's just the ln of the 4 ln of absolute value y. This one, how would we take, so now we have to take the integration, right? So this one's easy, right? This one, how would we take the integration of this? You would have to do partial fraction decomposition. So you need to know your partial fraction decomposition rule. So this will be set up like by FOIL at the minus, it's going to be negative v squared minus 1 over v times v plus 1 times v minus 1 equals to a over v plus b over v plus 1 plus c over v minus 1. And get rid of the fraction by multiplying both sides by the LCD, which is v plus 1 times v minus 1. So if you multiply everything by that, it gets rid of the denominator, and now you're left with negative v squared minus 1 equals to a parentheses v plus 1 times v minus 1 plus b v minus 1 plus c v times v plus 1. Okay. Then how would you solve for a and b? What you have to do is substitute a v value. So if v equals to 0, it would be 0 minus 1 equals to a, and then 0 plus 1 times 0 minus 1 plus b times 0 minus 1 plus c times 0 plus 1. And on the right, it's going to be a times 1 times negative 1 equals to -1. So that means A is equal to 1. And then if you set V as another value, let's say -1, it would be -1 minus 1 squared minus 1 equals to A times -1 plus 1 times -1 minus 1 plus B times -1 times -1 minus 1 plus C times -1 -1 plus 1, and then replace A with +1, and you should get B of -1 times -2, and then -1 squared is should be -2, and this would be 2B equals to -2. Solve for B. B equals to -1. So if B equals to -1, let V equals to 1, A equals 1, B equals to -1. So that's going to be 1 squared minus 1 equals to A plus 1. So left is -2 equals to 2C, and then you're going to get C equals to -1. Okay, so if you simplify, what's the left? So the left, you can take the integration both sides. So the left is going to be the integration. 4 is a constant, so you could take that out. And then on the left, we know our A, B, and C value, so it's going to be integration of 1 over V dV plus the integration of -1 over V plus 1 dV plus the integration of -1 over V minus 1 dV. This one's easy. The integration of 1 over V is absolute value of ln of V. This one, you would use U sub, and you're going to get negative ln of absolute value V U, or V plus 1. Same thing here. Use substitution, that would give you negative ln of absolute value V minus 1 plus C. Over here, this is going to be 4 ln of absolute value Y. Okay, what could we do here? On the right side, you can't really do much on the left, but on the right, we have ln of absolute value V minus ln of absolute value V plus 1 minus ln of absolute value V minus 1 plus C. This ln V is just ln of absolute value V. This one, remember when this is expanded, if we want to condense this into one natural log, it would be, well, when you're minusing, you're really dividing. So it's going to be minus ln of absolute value of V plus 1 times, so when you're minusing, you're actually, this should be a plus because there's an extra minus here. Yes. So now when you're adding and you're trying to condense logs, you're multiplying. So it's going to be V plus 1 times V minus 1 plus C. And then over here, if you have a number in front of them, log or natural log, that's like a power. So it's going to be the ln of y to the 4th. And then over here, you can condense it one more time. You can make it into one natural log. So this would be an ln of absolute value, and then you have a minus right in the middle, so that means divide. So it's going to be v over this whole thing. We know that v plus 1 times v minus 1 is a perfect square. So that's v squared minus 1. And then you would substitute your v equals x over y. We don't have a v. What we need is, oh, yeah, we do have a v. So you're going to substitute your v with x over y. So it's going to be ln of y to the fourth equals ln of absolute value of x over y over x over y squared minus 1 plus c. Then you've got to plug in your initial value. What was our initial value? Our initial value was uh, y2 equals 1 or 2 comma 1. You're going to plug in your initial value, plug 2 comma 1. Your x is 2 and your y is 1, right? That's going to be ln of 1 to the fourth equals ln x is 2 over 1 over 2 over 1 squared minus 1 absolute value plus c. So ln of 1 is 0. This is ln of 2 over 2. 2 squared is 4 minus 1, it's 3 plus c. So your c is going to be negative ln of 2 over 3. Okay, so your final answer will be ln of y to the fourth equals to ln of x over y over x over y squared minus 1 minus your plus your c, which is minus ln of 2 over 3. Oh, so on the right side, you can simplify it even more. They're both ln's and you have a minus in the middle. So what happens is you can write it into one single natural log or one single ln because minusing really means dividing. So you can say absolute value of x over y over x over y squared minus 1 all over 2 over 3. Right? And on the left, you have ln of y to the fourth. And then what you could do next is, okay, so wait, right here, if you simplify this, it's going to give you ln of 3 of x over y over 2 of x squared y squared minus 1, and then ln of y to the fourth. Now, can we solve for y? Yes, we can. What you have to do is take the e of both sides. So e raised to the e. So you get y to the fourth equals to 3 times x over y over 2 times x squared y squared minus 1. Okay, that is the last example of this lecture. So I'm going to stop here.